Question 3. In this question, I and j are our horizontal unit vectors. A particle P of mass 4 kilograms is at rest at the point A on a smooth horizontal plane. At time t equals 0, two forces F1, 4i minus j newtons, and F2, lambda I plus mu j newtons, where lambda and mu are constants, are applied to P. Given that P moves in the direction of the vector 3i plus j, show that lambda minus 3 mu plus 7 equals 0. Let's write down what we have first of all. I'm using the column vector notation here because I find it often works a little bit nicer when writing out the equations. It brings those I and j components in line. So F1, I can write column vector notation 4 over minus 1. F2 is lambda over mu. Now I'm looking at my resultant force here. If these two forces are acting on P, ultimately I want to add them together because I'm told that it's working in the same direction as the vector 3i plus j, which means that when I add them together, they are equal to some constant, which I'm calling n, multiplied by that directional vector, which is 3, 1. Now I'm going to find F1 plus F2. So here's my F1, 4 over minus 1, plus F2, and that is equal to, as I've stated, my constant, which I'm calling n, multiplied by my directional vector 3i. From this, I get two equations. I know that my 4 plus lambda is equal to 3n, and minus 1 plus mu is equal to n. A little bit nicer to write mu minus 1 is equal to n. Now these two equations both have an n, which ultimately I don't want in my show that. So let's multiply this bottom equation here by 3. Multiplying it by 3, I've got 3 mu minus 3 is equal to 3n. Now I have two equations equal to 3n, so I can write them equal to each other. 3 mu minus 3 equals 4 plus lambda. Rearranging that, lambda minus 3 mu plus 7 equals 0, which is what I wanted to show. Perfect. In part B, at time t equals 4 seconds, P passes through the point B. Given that lambda is equal to 2, find the length AB. So starting from my equation of lambda minus 3 mu plus 7, I'm going to put in my lambda is equal to 2. It's because I want to find my mu value. So rearranging this, I find that my mu is equal to 3. So I have my lambda is 2 and my mu is 3. I can now rewrite my forces. So my F1 is 4 over minus 1. That remains the same. But my F2 now with numerical values is 2, 3. This means my resultant force, so when I add these two forces together, my F1 plus 2 is 6, 2, or 6i plus 2j. Now I'm going to be using my good old F equals ma equation, where F is my resultant force, which I've just found to be 6, 2, and that's equal to the mass of this particle, which is 4 kilograms, multiplied by some vector for acceleration. Dividing through by 4, I get my acceleration to be 3 over 2, 1 over 2. Now I can use suvat. I want to find the position vector of this particle after it has moved for 4 seconds. We're starting at A and we're ending up at B after 4 seconds of movement. Notice the particle is at rest at point A. So my initial speed is 0. As a vector, that's 0i, 0j. S equals ut plus half at squared. R, therefore, is equal to 3/4 quarter times 16. So my position vector of R is 12i, 4j. Now this is the position vector of R, but not the length or the distance between A and B. For that, I need the magnitude of R, which is the square root of 12 squared plus 4 squared, which is root 160. Therefore, my length AB is equal to 4 root 10 meters.